This discovery was a surprise because Mercury's slow rotation, about once every 59 Earth days, had led scientists to believe that the planet could not generate a magnetic field. It's believed that Earth's magnetic field is generated by an interaction between the planet's faster rotation and its molten core. Mariner 10's discovery may change theories on how these fields are formed, and has given scientists their first opportunity to compare magnetic fields in the inner solar system.
Well, Mercury's magnetic field is a good deal weaker than the Earth's field or Jupiter's. Jupiter, in fact, has a stronger magnetic field than the Earth does. Mercury is about 100 times weaker. The surface magnetic field is about 1% of that on the Earth. It is similar to the Earth's, however, in the way that it interacts with the solar wind, the stream of plasma coming from the corona of the sun blowing past the planet at 400 or 500 kilometers per second. That solar wind compresses the magnetic field on the day side of the planet to a distance of about 1.5 planetary radii. And on the night side of the planet, it causes the magnetic field lines to stream out, so that although close into the planet, the magnetic field looks like a dipole, like what you'd expect from a bar magnet, as you've probably seen in high school science experiments. In fact, further away from the planet, it streams out into this shape dominated by the solar wind. And that's very much like the Earth's field. It has many of the same phenomena. The solar wind, for example, does not impinge directly on Mercury's surface, whereas it does impinge on the Moon's surface. Similarly, it doesn't impinge on the Earth's upper atmosphere.
While some characteristics of Mercury were unexpected, other features invited comparison. For instance, Mercury resembled the Earth's moon and seemed to be the product of a similar sequence of events.
The craters on Mercury are surprisingly similar to the craters on the moon. They show all the same features which we described for the moon. One small difference is that smaller craters will be collapsed, so that typically craters 15 kilometers across have terraces and central peaks, whereas craters in that size range on the moon, for the most part, are uncollapsed. They're simpler in form. Another feature which is direct, this is related to the difference in the gravitational field at the surface of Mercury. It's much higher on Mercury than it is on the moon. And another feature which we see is that the secondary craters, the swarms of secondary craters, are closer to the main crater. And that too is related to the stronger gravitational field at the surface of Mercury. In other words, material that's thrown out doesn't go as far on Mercury. It lands closer in and makes closer secondary craters. In fact, all of our ability to compare the details of the craters on Mercury with the craters, the young, fresh craters on the moon, confirms all of our expectations about the ballistic transport of material and about the principal processes by which these craters have been produced.
And that's extraordinary, because Mercury is very different inside compared to the moon. And that means it must have had a different history of heating and modification of the surface from the inside. And furthermore, it lives in a very different part of the solar system, much closer to the sun. And therefore, it must have experienced a different exterior history as well. And yet, the pictures show that Mercury has a surface history very similar to that of the moon.
One would expect that little Mercury, closest to the sun, would be the hottest planet in the solar system. But strangely, that dubious honor belongs instead to the next planet, nearly twice the distance from the sun, mysterious, cloud-covered Venus. Only slightly smaller than the Earth, perpetually covered with dense clouds and moving in the same general part of the solar system, Venus was often referred to as the Earth's twin. Closer to the sun and therefore warmer, it was even speculated that Venus might be covered with lush tropical rainforests under the dense clouds. But in the 1960s, Mariner spacecraft and Earth-based radar began to reveal a much different Venus. The planet slowly rotates backward once every 243 Earth days. Its carbon dioxide atmosphere is so massive that on the planet's surface, the pressure is 91 times greater than atmospheric pressure here on Earth. That's the pressure a diver would experience 1,000 meters below the surface of the ocean. And if that's not enough, the daytime temperatures soar to nearly 900 degrees Fahrenheit. But during the long Venusian night, 121 Earth days, it does cool down to only 600 degrees. It seems most unlikely that man will ever set foot on our nearest neighbor. The fact that Venus is somewhat closer to the sun could account for its being about 90 degrees hotter than the Earth. But in fact, it's 800 degrees hotter. This is attributed to a runaway greenhouse effect. Most of the sunlight that falls on Venus is reflected back into space by the planet's dense cloud layers, and that's one reason Venus appears so bright in our skies. But the sunlight that does penetrate the atmosphere reaches the ground and heats up the rocks and soil. The warm rocks and soil then radiate this energy as infrared heat, and the carbon dioxide atmosphere tends to trap some of this infrared heat near the surface, thus raising the surface temperatures. Much the same thing happens to a glass-covered greenhouse or a closed automobile on a sunny day, because glass readily lets the sunlight in, but traps the infrared heat inside. And of course, discovering this effect on Venus makes us wonder if it could ever happen here on our planet, either because of or in spite of human activity. Very recent predictions are that the Earth's surface temperature is in fact slowly rising due to increasing atmospheric pollution. A view of the inferior planets from above would show that both Mercury and Venus's orbit are between the Earth and the Sun. Using one arrow to represent the line of sight from the Earth to the Sun, and another arrow for the line of sight from Earth to Venus, since Venus lies inside the Earth's orbit, the planet seems to move back and forth in relation to the Sun. For 9.5 months, Venus lies to the east of the Sun, and so we see it in the western sky as the bright evening star. And if we follow its motion below the horizon, Venus swings through conjunction to the western side of the Sun, where we then see it as the bright morning star rising in the east before sunrise. With a telescope, we can note, as did Galileo, that Venus exhibits all the phases of our moon. The bright portion is the part illuminated by the sun, and the rest of the planet is the dark side, the side facing away from the sun. It's important to remember that Venus, like all planets, shines by reflected sunlight. It's the brightest object in the sky after the sun and the moon, because it comes so close to the Earth and because its dense cloud layer is so reflective. But that same dense cloud layer has prevented us from even glimpsing from Earth any details on the surface of Venus. Mariner 10 flew past Venus en route to Mercury in 1973. Several thousand ultraviolet photographs were transmitted back to Earth. They showed details of an atmosphere which swirls around the planet every 4 days, 50 times faster than the rotation of the planet. Why? The question remains unanswered, just as the surface remained hidden from Mariner's prying cameras. In 1978, 2 Pioneer spacecraft arrived at Venus. One went into orbit around the planet. The other sent 5 separate instrument packages into the Venusian atmosphere. From Earth, we see light reflected from upper cloud layers about 60 kilometers above the surface. It's very cold there, well below the freezing point of water. These high clouds form 2 distinct layers. The upper one is mostly drops of sulfuric acid. The lower opaque layer is solid and liquid sulfur mixed with sulfur dioxide. Below this main cloud, a haze extends about 32 kilometers altitude. Below that is clear, dense carbon dioxide with a little nitrogen and traces of water vapor, argon, oxygen, and neon right down to the surface.
This isn't really a recreation of the conditions on the surface of the planet Venus, but if you wanted to get a whiff of the atmosphere, this is at least the place to start. This carbon dioxide is produced by cakes of dry ice which is, of course, frozen carbon dioxide, and not the way in which we'd find that chemical on the surface of the planet Venus. Most of the atmosphere of the planet Venus is carbon dioxide as a gas. Of course, on Venus, the carbon dioxide is at a much higher temperature, and in fact, at a much higher pressure as well. And to make it really like the planet Venus, we'd also have to lace it with a little sulfuric acid. Add a little bit of the feeling of air pollution that we're so used to, of course, in our major cities. And this gas is going to weigh much more heavily upon our shoulders because the atmospheric pressure on the planet Venus is about 100 times that on the surface of the Earth. In addition, we would expect to find a much higher temperature on the surface of Venus, about 900 degrees Fahrenheit. So high temperature, high pressure, and a gas that we can't breathe make life on Venus rather unpleasant. That combined with a barren landscape of rocks, some of them which have eroded away somewhat smooth, mixed in with volcanoes, probably craters, who knows what other kinds of geological features yet to be discovered, make Venus a rather unpleasant place to live.
We expect that the atmosphere of Venus, like that of Earth, originated by outgassing from the crust. And indeed, the total amount of nitrogen is about the same as on Earth. And so is the amount of carbon dioxide, except that here on the cooler Earth, it has reunited with surface rocks. However, the major compound to outgas on Earth was water. But where is the Venusian water?
And that question hasn't been answered, but it's a very interesting one. There are two theories. Perhaps Venus never had water because during the formation of Venus, the water boiled away in some sense. And the other possibility is that Venus started off similar to the Earth, but the water boiled away after the planet formed. In both cases, the proximity to the sun is the controlling factor.
Our detailed knowledge of the surface of Venus comes from two sources, the Pioneer orbiter and several Soviet Venera landers. Since 1978, the Pioneer Venus orbiter has used radar to map most of the surface. We find a planet that is flat to within a few kilometers. On this map, red indicates the highest elevations, orange and yellow are continental plateaus, and the dark colors identify low plains. There are some features which resemble the continents on Earth, but no water, no oceans. In the far northern hemisphere is Ishtar Terra, a region about as large as the Soviet Union, 4 to 5 kilometers above the Venusian plains. On Ishtar Terra, we find the largest mountains, Maxwell Montes, soaring to 6 kilometers above the continent. Beta Regio is a small continental region about the size of Alaska and may be a region of active volcanism. Periodic volcanic eruptions would explain the varying amounts of sulfurous gases found high in the Venusian atmosphere. Just below the Venusian equator, we find Aphrodite Terra, a narrow continent extending nearly a third of the way around the planet. There are valleys and canyons on Venus, including a great rift valley 1,400 kilometers long. Several large ring-like features may be remnants of impact craters. Several Soviet Venera landers have given us brief glimpses of the surface in detail before the landers succumbed to the hellish surface environment. In the mid-1970s, Venera 9 and 10 each sent back one panoramic view of their landing site.
So in each case, Venera 9 and Venera 10, they got one panoramic view of the horizon that they would see by looking down at 45 degrees and swiveling the camera. Now, it's quite remarkable that they were able to take these pictures without turning their floodlights on, because we did not expect it to be that bright at the bottom. And furthermore, what they saw is rather remarkable and in a certain sense disappointing, because these pictures seem to indicate for the two regions on Venus where they've now scanned from horizon to horizon, that's about the size of a football field, they see nothing but boulders. The boulders appear to be in a size range from maybe 1 or 2 meters down to a few centimeters. These two regions they've landed on are absolutely boulder strewn, and that is quite different than the average place on the Earth where there's a great deal of soil. And it's totally different, of course, from the Moon where it's almost all soil. Blocks and rocks are relatively rare on the surface of the Moon. It's more like Mars. You remember the Viking pictures of Mars show a fair number of rocks sitting around, but you have to increase that by a factor of 10, as one can see from the pictures that the Russians have taken of the surface of Venus. So the planet is different in that way from the other terrestrial planets. For some reason, at least in the two little football field regions that it's been measured, it has a great deal more rock in the surface instead of soil.
In the early 1980s, another Venera lander sent back a photo of a different part of Venus. In the lower center is the bottom of the spacecraft. It has landed in a region of surprisingly flat rock, extending off toward the horizon in the corner. These flat areas may indicate ancient lava flows and be further evidence of a history of volcanic activity on Venus.
Venera 13, which landed first, shows you sort of a wide swath picture of Venus's surface. And the geometry of these pictures is a little peculiar to understand. In the center of the picture, you're looking almost straight down, and on the sides, you're looking away from the spacecraft. So as you look down at the center, you mainly see your feet, or the base of the spacecraft. And on it, you see a little arm which is extending down, touching the surface, meant to measure the strength, a little bit about what the surface is like. Next to it is a half-moon-shaped lens cap, which pops off the camera in order to expose the camera to light. Off in the corners, you can actually see pieces of the horizon. A remarkable thing about the photographs is that it gives you a very clear view of what the surface of Venus looks like, a very, very hostile, faraway environment. And what we found are what appear to be flat, eroded volcanic rocks, and some of the geochemical measurements that were made indicate that they're very similar to some volcanic rocks found on Earth. There's other evidence, both from the U.S. and the Soviet spacecrafts orbiting Venus, that Venus is a volcanic planet and may have actually very young volcanism. The Venera 14 photograph gives you a slightly different view, and it almost looks like you landed in a broken up region of cobblestones, and again, flat, eroded rocks appear to be volcanic. One interesting thing about the Venera 14 picture is that if you look at the little probe that comes down onto the surface, it happened to have landed right on top of the lens cap. So it's kind of a clear illustration that Murphy's law, the law that if something can go wrong, it will, is a universal law. It's even interplanetary. The main pieces of evidence to indicate that there's active volcanism on Venus, and in fact it's a geologically active planet, come from, one, the ground-based radar measurements, images of the planet, and the Pioneer Venus radar images of the planet. They indicate that the surface is made up of broad, flat regions with mountainous areas, indicative of what we have on Earth as interplate volcanism, things like the Hawaiian volcanic shields.
Once we saw these remarkable photographs from the Venus space missions, our romantic notion of a world with lush tropical jungles and frolicking Amazons waiting to greet visitors from planet Earth simply had to end. This pleasant fantasy of a swampy twin to planet Earth evaporated in the harsh reality of a world that was more like hell than any other place in the solar system.